You are sitting somewhere familiar. A room, a chair, a screen glowing quietly in front of you. Your thoughts move at a comfortable pace, one after another, as they always have. The world around you appears steady and dependable. Objects remain where you leave them. Moments arrive, pass, and become memories. This rhythm feels so natural that you rarely question it. You assume that time flows the way a river flows, carrying everything forward in a continuous, irreversible current. Every clock you have ever seen agrees with this assumption. Every schedule, every heartbeat, every sunrise seems to confirm it. And yet, hidden beneath this ordinary experience is a growing problem. Across physics and cosmology, the deepest theories we possess no longer treat time as something fundamental. In the equations that describe the universe at its most basic level, time often disappears entirely. Experiments in quantum mechanics show events occurring without any clear temporal order. Relativity reveals that different observers can disagree on what happened first. Black holes suggest that time can freeze, stretch, and even dissolve. The more precisely scientists examine reality, the less solid time becomes. You live inside something that feels like time, but the universe may not. The question is no longer whether time behaves strangely. The question is far more disturbing. What if time is not truly there at all? The assumption. You never question. You were taught, without ever being told directly, that time is the stage on which everything happens. It feels older and more basic than anything else you know. Before you understood language, before you formed memories, before you recognized your own reflection, time was already carrying you forward. Because of this, you have never needed to ask what time actually is. You simply experience it. Seconds follow seconds. Days follow days. The idea that time might require an explanation seems unnecessary until you look closely at what physics has discovered. From the moment you wake each morning, your life is organized around this invisible framework. Alarms ring at specific hours. Meetings are scheduled. Meals are planned. You speak naturally of wasting time, saving time, running out of time, as if it were a physical substance you could hold in your hands. Every language you know treats time as something obvious, something so fundamental that it barely needs to be defined. You move through it the way a fish moves through water, unaware that you are submerged in an assumption. But familiarity is not the same as understanding. You have never seen time. You have never touched it. No instrument has ever detected a particle of time or isolated a fragment of it in a laboratory. What you experience are only events: the rotation of Earth, the beating of your heart, the changing light outside your window. Time is the name you give to the ordering of those events, yet you rarely notice this distinction. The ordering feels so natural that you mistake it for a physical thing. This habit runs deeper than logic. It shapes the way you imagine reality itself. When you picture the universe, you imagine space filled with objects and a separate stream called time pushing everything forward. You assume that even if every star vanished, time would continue on its own, that it existed before the universe and will exist after the last process ends. This picture is intuitive. It is also unsupported by anything science has ever measured. Physics did not begin by questioning time. Early scientists accepted it just as you do, as a universal background against which motion could be described. The first equations of motion took time for granted. It was a parameter that needed no explanation. But as those equations became more precise, small cracks began to appear. Observations accumulated that did not fit comfortably inside the simple picture you inherited. The problem is subtle because everyday experience never contradicts your assumption. On human scales, time behaves politely. It seems uniform and reliable. Your clocks agree with one another. Causes appear to come before effects. Yesterday feels permanently fixed, and tomorrow feels open. Nothing in ordinary life forces you to doubt this arrangement. Science, however, is not built on ordinary life. It is built on extreme precision, when measurements grew accurate enough. The comfortable idea of a single universal time began to fail. Experiments showed that clocks in different conditions do not agree. The rate at which time passes depends on speed and gravity. Events that appear simultaneous to you are not simultaneous to someone else. The very foundation you assumed was solid started to shift under examination. And yet, despite all of this, you continue to live as if time were the most basic element of existence. You plan your future, remember your past, and move through your days convinced that you know what time is or was. The assumption is woven so tightly into your thinking that questioning it feels almost absurd. But physics has learned to question the absurd. It has learned that the most obvious features of reality are often the most misleading. The ground feels flat, yet it is curved. The sun appears to circle the earth, yet the opposite is true. Solidity feels fundamental, yet matter is mostly empty space. Again and again, science has discovered that what seems self-evident can be profoundly wrong. Time now stands in that same vulnerable position. What you take as the unquestionable backdrop of existence may be nothing more than a convenient perspective created by the limits of human perception. The stage you believed everything was built upon might itself be only another actor in a deeper drama. And the moment you begin to suspect this, the certainty you have carried since childhood starts to dissolve. Clocks do not measure what you think. You believe that a clock measures time itself. But a clock only measures motion. The swinging of a pendulum, the vibration of a crystal, the decay of an atom. These are physical processes, not time. When you check the hour, you are not observing time directly. You are comparing one motion to another. Every device you have ever trusted to track time is really just a machine counting changes. This works perfectly in daily life. Yet it hides a subtle but critical fact. Time is never observed on its own. Consider what actually happens when you look at a clock. Hands rotate across a dial. Numbers change on a screen. Tiny gears turn, or electrical signals oscillate billions of times per second inside a crystal. None of these mechanisms contain anything that could be called time. They contain only movement and transformation. You call one rotation of the Earth a day. You call a certain number of atomic vibrations a second. But these are agreements, not revelations. The clock does not capture time. It creates a pattern you have chosen to treat as a standard. If every clock on Earth suddenly stopped, time would not pause with them. Events would continue exactly as before. Stars would still burn. Hearts would still beat. Rivers would still flow. This simple thought exposes the hidden truth. Clocks do not control time, and they do not reveal its nature. They merely provide a convenient way for humans to coordinate experience. Even the most advanced clocks ever built do nothing more than refine this basic idea. Atomic clocks are often described as measuring time with extraordinary precision. But in reality, they only measure extraordinarily stable physical cycles. When scientists say a second is defined by a specific number of cesium atom vibrations, they are admitting something important. The unit of time is defined by motion. Without motion, the definition collapses. You have grown so accustomed to this arrangement that it feels inevitable. Of course, a clock measures time, you assume. What else could it measure? But physics forces you to confront a deeper question. If time were truly a fundamental feature of the universe, why can it never be detected directly? Why must it always be inferred from change? Imagine trying to measure space without using any physical objects? You could not. Distance only becomes meaningful when there are things to compare. In the same way, duration only becomes meaningful when there are events to compare. This parallel suggests that time may not be a substance flowing independently, but a way of describing relationships between processes. Every historical attempt to grasp time more directly has failed. No experiment has ever isolated a fragment of pure time. No instrument has ever registered its passage apart from physical change. Scientists can detect particles, fields, and forces. They can measure energy and momentum. But time itself remains strangely absent from the list of measurable things. And yet, your confidence in clocks remains unshaken. When two clocks disagree, you assume one must be wrong. You never assume that time itself might not be what you think it is. But relativity has already shown that clocks in different conditions genuinely do disagree, and that none of them can claim absolute correctness. Each simply tracks its own local rhythm of motion. This leads to an uncomfortable realization. The entire human concept of time is built on an elaborate system of comparisons. Sunrise to sunrise, tick to tick, pulse to pulse. You have mistaken the regularity of certain physical processes for a universal river carrying everything forward. But the river has never been found. Only the processes exist. The more carefully you examine this, the stranger it becomes. If time cannot be observed without change, and if change can only be defined using time, then the concept begins to circle back on itself. You rely on clocks to tell you that time is passing, but clocks rely on the assumption of time to make sense in the first place. What you call the measurement of time may be nothing more than the measurement of the universe rearranging itself. And if that is true, then time is not the fundamental reality you have always imagined. It is only a name you give to motion, mistaken for something deeper. Relativity removes the universal. Now, you imagine that this moment is shared by everyone, everywhere, that there is a single, universal present moving steadily through the cosmos. Einstein's relativity proved that this comforting picture is wrong. Two observers moving differently through space can disagree about whether two events happened at the same time. There is no cosmic clock ticking for the entire universe. What feels like a common now is only a local illusion created by your particular motion. This idea is difficult to accept because it contradicts everything your senses suggest. When you speak to someone on the phone, you assume you are both experiencing the same instant together. When you watch a live broadcast, you believe the events on the screen belong to the same present you occupy. Everyday life encourages the belief that the universe shares a synchronized heartbeat. Relativity dismantles that belief with simple logic. Imagine two events occurring far apart in space: a flash of light on one planet and a flash of light on another. To you, standing in one state of motion, they might appear to happen at exactly the same time. To another observer, moving at high speed relative to you, one flash will occur first and the other second. Neither of you is wrong. The laws of physics allow both descriptions. Simultaneity itself becomes relative. This means that the present moment is not a global slice through reality. It is a personal perspective, dependent on where you are and how you are moving. The universe does not possess a single master timeline on which all events can be neatly arranged. Instead, it contains countless overlapping versions of now, each valid for a different observer. The implications are profound. If there is no universal present, then the idea of time as a single flowing river cannot be correct. A river has one direction and one current, but relativity reveals a landscape where different observers carve different paths through the same set of events. What you call the present is merely the particular cross-section of space-time that your motion happens to define. You can sense how unsettling this is when you follow the logic to its conclusion. Somewhere far away, at this very instant, according to you, events are occurring that another observer would say belong to your future. And events you consider already finished may still lie ahead in someone else's version of now. The neat separation between past, present, and future begins to blur. Nothing in your daily experience prepares you for this. Human intuition evolved in a world of slow speeds and weak gravity, where these differences are far too small to notice. On Earth, the illusion of a shared present works well enough, but the universe is not obligated to respect your intuitions. Relativity shows that time is woven together with space into a single structure. To speak of time alone, independent of motion and position, is to ignore how reality actually behaves. What you experience as the steady march of moments is only your individual route through that structure. Even the phrase "right now" loses objective meaning. There is no location in the cosmos you could point to and declare this is the true present of the universe. Physics provides no mechanism for such a thing. Every clock, every observer, every planet carries its own local definition of now, none privileged above the others. This does not merely adjust your understanding of time, it overturns it. The comforting idea that the entire cosmos is advancing together from past to future dissolves under scrutiny. Instead, you are left with a fragmented picture where different observers inhabit different temporal orders. The universe no longer resembles a synchronized story unfolding page by page. It resembles a vast four-dimensional structure in which all pages already exist, arranged differently depending on how you look at them. And if the present is not universal, if there is no single moment that the cosmos collectively occupies, then the flow of time you feel so vividly cannot be a fundamental feature of reality. It must be something else, something local, something constructed, something far less solid than you have always believed. The speed of time is not fixed. You assume that time flows at the same rate everywhere. Physics shows the opposite. Near massive objects, time slows down. At high speeds, time stretches. Satellites orbiting Earth must constantly correct for this effect, or their clocks drift out of sync. Time is not a rigid background. It bends and warps like space does. Something that can stretch and shrink cannot be a simple, fundamental container for reality. It begins to look more like a side effect. This is not a philosophical idea. It is a measurable fact. Every day, navigation system, orbit rely on precise clocks to determine positions on Earth. Those clocks experience time differently than clocks on the ground. The difference is tiny, but real. If engineers ignored it, the entire system would quickly fail. The functioning of modern technology depends on accepting that time itself changes speed depending on where you are and how you move. Think about what that means. You are accustomed to believing that 1 second is always 1 second, everywhere in the universe. Relativity shows that this is not true. A second near a black hole is not the same as a second in empty space. A second for an astronaut traveling at extreme velocity is not the same as a second for someone resting on Earth. Duration is not absolute. It is flexible. This flexibility undermines the very idea of time as a universal stage. A stage does not stretch or compress depending on who stands upon it. If time were truly fundamental, it would be the same for all observers, under all conditions. Instead, it behaves like a material affected by gravity and motion, shaped by the physical world rather than standing apart from it. You can imagine two identical twins, one remaining on Earth and the other traveling through space at high speed. When they meet again, one will have aged less than the other. Not because of biology or technology, but because time itself passed at different rates for them. The flow you consider constant becomes personal and variable. This effect is not limited to exotic situations. Even climbing a mountain changes the rate at which you move through time, though by an amount too small for your senses to notice. The top of a skyscraper experiences time slightly faster than the street below. Every location in the universe carries its own private tempo. Such behavior is deeply strange if you cling to the intuitive picture of time as an independent entity. But it makes perfect sense if time is something that emerges from the structure of space-time itself. In relativity, gravity is not a force pulling on objects. It is a curvature of space-time. And when space-time curves, time curves with it. This leads to a subtle reversal in perspective. You do not move through a fixed timeline. Instead, the geometry of the universe determines how time unfolds for you. The rate at which your clocks tick is a consequence of your environment, not a fundamental constant written into the fabric of existence. The more extreme the conditions, the more obvious this becomes. Near a massive star, time runs noticeably slower. Close to a black hole, it can slow almost to a halt relative to distant observers. If you could watch someone approach the edge of such an object, you would see their movements freeze, stretched across eternity. To them, however, time would feel normal. There is no single truth about how fast time is moving. This shatters the last remnant of the old, comfortable picture. You cannot claim that time flows uniformly throughout the cosmos, because experiments prove otherwise. You cannot treat it as a background independent of matter and energy, because matter and energy directly alter it. Time behaves less like a ruler and more like a rubber sheet. And a rubber sheet is not fundamental. It is a surface shaped by deeper forces. If the speed of time depends on physical circumstances, then time itself must depend on physical circumstances. Something truly basic would not vary from place to place. It would not slow, stretch, or twist. Yet time does all of these things. What you call the passage of time is beginning to resemble a local effect, produced by the universe, rather than the framework that produces the universe. And once you see this clearly, the idea of time as an underlying reality becomes increasingly difficult to defend. Cause and effect begin to blur. Your entire understanding of the world depends on cause preceding effect. You drop a glass, then it shatters. You flip a switch, then a light turns on. But relativity allows situations where different observers disagree on the order of events. Quantum experiments create correlations that seem to ignore temporal sequence altogether. The bedrock logic of before and after starts to weaken when examined closely enough. Time no longer looks like the master rule. It looks like an approximation. From childhood, you learned to navigate reality through this simple principle. Actions lead to consequences. The past produces the present. The present shapes the future. Every decision you make relies on this structure. Without it, planning would be impossible and memory would have no meaning. Cause and effect feel like the most secure truths you possess. Yet physics reveals that this structure is not as solid as it appears. In relativity, the order of certain events is not fixed. If two occurrences are separated by enough distance and not connected by any signal traveling at or below the speed of light, then different observers can legitimately disagree about which came first. What looks like a clear sequence to you can appear reversed to someone else moving differently through space-time. The universe does not enforce a single global chronology. This does not destroy causality entirely, but it weakens the framework you instinctively rely upon. The neat chain of before and after becomes dependent on perspective. Temporal order, which you assumed to be an objective feature of reality, turns out to be partly a matter of viewpoint. Quantum mechanics pushes this confusion even further. Experiments with entangled particles show connections that ignore ordinary temporal logic. Two particles can be separated by vast distances, yet measurements performed on one instantly correlate with measurements on the other. No signal travels between them. No clear cause precedes a clear effect. The relationship simply exists outside the familiar sequence of events. In more advanced experiments, physicists have created situations where it is impossible, even in principle, to determine which of two actions happened first. The results remain consistent, regardless of how you try to impose an order upon them. Nature behaves as though the concept of temporal sequence does not always apply at its deepest level. This is profoundly unsettling, because your mind is built to think in chains of causation. You assume that the universe operates like a story, one moment leading naturally to the next. But modern physics suggests that this narrative structure may be a simplification imposed by human perception. If causes and effects can blur, overlap, or lose their order entirely, then time can no longer be the firm scaffolding you believed it to be. Instead of a strict highway guiding events forward, it begins to resemble a rough map drawn after the fact, useful but incomplete. Even classical physics hints at this fragility. The fundamental equations that govern motion work equally well forward or backward. Film a collision between billiard balls and play it in reverse, and the motion still obeys the same laws. Nothing in those equations insists that one direction must be labeled cause and the other effect. The distinction arises only when large numbers of particles and messy real-world conditions are involved. Your confidence in causal order comes primarily from everyday experience, not from the deepest rules of nature. At human scales, events arrange themselves neatly enough that the illusion holds. But when scientists probe smaller scales or extreme conditions, the tidy sequence begins to unravel. This does not mean that anything can cause anything else at random. Patterns still exist. Regularities still hold. But the foundation beneath those patterns is stranger than you were taught. Causality appears to emerge from deeper principles rather than defining them. And if cause and effect are not absolutely anchored in time, then the flow of time itself becomes suspect. The direction you call forward may be less a property of the universe and more a habit of thought, reinforced by the limited conditions in which you evolved. What you experience as a strict progression from past to future may be only a convenient story your brain tells to organize events that, at a fundamental level, do not require such a story. Once this possibility is taken seriously, the entire familiar structure of time begins to feel less like an unbreakable law and more like a practical illusion. An illusion powerful enough to guide your life, but not powerful enough to describe reality completely. The quantum world ignores time. At the smallest scales of reality, the equations of quantum mechanics often do not contain time in any meaningful way. Particles exist in states that evolve according to probabilities, not ticking seconds. Entangled particles influence one another without any measurable delay. Experiments show outcomes that appear to be decided outside the flow of time you experience. The deeper physics looks, the less it relies on the concept you call time. This is not immediately obvious because quantum theory is usually introduced using familiar language. Textbooks describe particles moving, changing, interacting. But beneath that language lies mathematics that is strangely indifferent to temporal order. The most fundamental object in quantum mechanics is not a particle following a path through time. It is a wave function, a mathematical description of possibilities that exists all at once. When physicists calculate how a quantum system behaves, they often do so without specifying any particular moment. The equations describe relationships between states rather than events unfolding second by second. Time can be added as a useful parameter, but it is not essential in the way you would expect. The core structure of the theory does not depend on a flowing present. Consider quantum entanglement, one of the most carefully tested phenomena in science. two particles become linked so that measurements on one are instantly correlated with measurements on the other, no matter how far apart they are. This connection does not wait for a signal to travel. It does not unfold gradually. It simply exists. From the perspective of the equations, nothing moves from past to future. The relationship is timeless. Experiments designed to probe this behavior grow more sophisticated each year. Researchers have demonstrated entanglement across cities, between ground stations and satellites, even in situations where the order of measurements is deliberately made ambiguous. The results remain consistent. The correlations appear without any need for a temporal sequence to guide them. This suggests something deeply uncomfortable. At the quantum level, the universe does not seem to care about your intuitive notion of before and after. Processes occur as patterns of probability rather than as stories progressing through moments. These machinery of reality functions perfectly well without invoking a ticking clock. Even the act of measurement, which feels like something happening at a specific time, is more subtle than it appears. In many interpretations of quantum mechanics, the outcome of an experiment is not determined by a chain of causes reaching forward from the past. Instead, it is described as a global constraint, a relationship among all parts of the system considered together. The language of temporal progression becomes optional. You can sense how foreign this is to ordinary thinking. Your entire inner life is structured around sequences. Thoughts follow thoughts. Actions follow intentions. But quantum mechanics describes a world where the most basic ingredients do not behave this way. They exist in superpositions that are not located at any single instant. They transform according to rules that make no reference to a universal now. Attempts to combine quantum mechanics with gravity make this tension even clearer. In several leading approaches to quantum gravity, time disappears entirely from the fundamental equations. The universe is represented as a static mathematical object, with change emerging only as an approximate description at larger scales. From this viewpoint, the flow of time is not a building block of reality, but a rough summary of deeper, timeless relationships. None of this violates any experiment you can perform. On human scales, the quantum strangeness averages out, and the world behaves as though it unfolds moment by moment. But the smooth continuity you experience may be nothing more than a convenient illusion produced by enormous numbers of microscopic interactions. The closer scientists look, the more they find a realm that operates without any need for temporal scaffolding. What you call time becomes a tool for organizing observations, not a feature built into the foundations of nature. And if the most accurate theory ever created can function without relying on a time, then the role of time in your picture of the universe must be far less fundamental than you have always assumed. At the deepest accessible level, reality appears to proceed perfectly well without it. The block universe. You already live inside relativity suggests a picture of reality known as the block universe. In this model, past, present, and future all exist together as a single four-dimensional structure. Nothing truly moves from one moment to the next. Instead, every event simply occupies its location in space-time, like pages already written in a finished book. What you call the passage of time becomes only the path your consciousness traces through a fixed landscape. This idea feels unnatural because it conflicts with the most basic feature of your inner life. You feel time flowing. You remember yesterday and anticipate tomorrow. The future appears open, and the past appears settled. Yet relativity, the most thoroughly tested theory of space and time ever created, does not contain any mechanism for such flow. Its equations describe a universe that simply exists, all at once. To understand this, imagine space-time not as a sequence of moments, but as a complete structure. Every event that has ever happened, and every event that will ever happen, is already positioned within this structure. Your birth, this instant, and your final day are all points in the same four-dimensional geometry. From this perspective, nothing is becoming. Everything already is. The block universe does not emerge from philosophical speculation. It emerges directly from the logic of relativity. If different observers can disagree about which events are simultaneous, then there can be no single moving present slicing the universe into past and future. The only consistent way to describe reality is to treat all moments as equally real. Once this is accepted, the idea of time as a river carrying you forward loses any scientific foundation. You can picture this by thinking of a film, Reel. When you watch a movie, the scenes appear to unfold in sequence. Characters move, stories progress, time seems to pass. But the entire film already exists on the reel. The motion is produced only by the projector, revealing one frame after another. The block universe suggests that reality is more like the reel than like the projection. In this picture, change does not occur because moments replace one another. Change exists because different regions of space-time contain different arrangements of matter and energy. The feeling that the present moment is advancing is not written into physics. It is something generated inside your mind as it navigates the static terrain of events. This does not make your experiences unreal. It simply reframes them. You are not a traveler being carried through time. You are a pattern extended across space-time, aware of only a thin slice of yourself at any given point. Your memories are records located in one region of the block. Your expectations are processes located in another. The sense of movement arises from how these regions are connected. The more carefully you examine this view, the harder it becomes to escape. Every scientific description of the universe treats events as existing within space-time rather than being created by it. Equations do not evolve in time. They describe the whole structure at once. Physics never requires a flowing now to function. And yet your intuition rebels. If the future already exists, you wonder, why does it feel uncertain? If the past still exists, why can you not return to it? The block universe answers these questions in a way that is logically consistent, but emotionally unsettling. You cannot access other moments for the same reason you cannot be in two places at once. They are simply different locations in space-time. Freedom and uncertainty do not vanish in this model. They become features of your limited perspective. From within the block, you possess only partial information, so the future appears open, even if, in the full structure, it is already laid out. This view strips time of its privileged status. Instead of being the engine of reality, it becomes part of the geometry. The universe no longer needs to progress from one state to another. It simply contains all states together. You continue to experience a moving present because your consciousness can only process events sequentially. But physics offers no evidence that such movement occurs outside your perception. If the block universe is correct, then you have never truly traveled through time at all. You have always been living inside it, fixed within a structure far larger and stranger than the moment you believe you occupy. Motion without movement. If the block universe is correct, then change is not fundamental. All events already exist. The sensation that the present moment is advancing may be produced entirely inside your mind. You feel as though you are traveling through time, but physics describes no mechanism for such movement. The equations depict a complete structure, not a process unfolding. Time begins to resemble a perspective rather than a force. This is the central tension at the heart of modern physics. Your inner experience insists that moments arrive one after another. The mathematical description of the universe insists that they do not. Nowhere in the laws of nature is there a rule that pushes the present forward. Nothing in relativity or quantum mechanics requires a flowing instant. The universe works perfectly well without it. Think carefully about what it would mean to truly move through time. Movement in space requires a direction and a speed relative to something else. But what would it mean to have a speed through time? Speed is already defined using time. To move through time would require a second kind of time to measure the movement, leading to an endless loop. Physics avoids this paradox by never introducing such motion at all. Instead, the theories describe a static arrangement of events. A falling object is not portrayed as traveling from one moment to the next. It is represented as a continuous world line drawn through space-time, a complete curve existing all at once. Your life, from birth to death, forms a similar line. From the outside, nothing about it needs to change. It simply is. Yet from the inside, you experience that line as a journey. This difference between description and experience is crucial. The block universe does not deny that you feel motion. It denies that this feeling corresponds to any physical process. Just as your brain creates the sensation of color from wavelengths of light, it may create the sensation of temporal flow from patterns of memory and perception. Consider how a flipbook animation works. Each page is a still image. Nothing on the paper moves. But when you view the pages in sequence, motion appears. The movement exists only in the act of viewing, not in the images themselves. The block universe suggests that reality functions in a similar way. The events are fixed. The motion arises from how your mind encounters them. This reframing changes the role of time completely. Instead of being the engine that drives the universe, time becomes a coordinate, like north or east. A coordinate does not move. It simply labels positions. What you call the flow of time becomes the order in which your consciousness accesses those positions. The idea is unsettling because it removes something you thought was essential. You imagine that the universe is continuously becoming, that each new second is freshly created. Physics offers no evidence for such creation. It offers only relationships between different parts of an already existing whole. Even the language you use betrays how deeply the illusion is rooted. You speak of the present moving forward, of the future approaching, of the past falling away. But in the block universe, none of these metaphors have literal meaning. The past has not gone anywhere. The future is not waiting to arrive. All of it simply occupies different regions of space-time. This does not make your decisions meaningless or your experiences unreal. It means that their reality does not depend on a moving now. Your choices are part of the structure just as surely as mountains and galaxies are. They do not need to be created moment by moment to be genuine. The deeper question is why you feel motion at all, if no such motion exists. Neuroscience offers partial clues. Your brain constantly compares incoming information with stored memories, constructing a narrative that links one state to the next. That narrative is interpreted as the passage of time. The sensation is powerful, but it may reveal more about how minds work than about how the universe works. When you step back and look at the full picture provided by physics, the familiar flow of time begins to look like a user interface layered over a timeless reality. A useful interface. Perhaps a necessary one, but not the underlying truth. And once this possibility is taken seriously, the world you thought you understood becomes far stranger. You remain convinced that you are moving, but the universe offers no evidence that anything of the kind is happening. Entropy and the illusion of flow. You were told that time moves forward because entropy increases. Disorder grows. Eggs break, but never unbreak. Yet entropy does not create time. It only gives direction to processes within a universe that already exists. The laws of physics work just as well, forward or backward. Nothing in them demands a flowing present. The arrow of time may simply be a statistical pattern, not a fundamental feature of reality. Consider the physical meaning of entropy. It is a measure of how many ways a system can be arranged. When a cup of hot coffee cools in a room, the heat disperses, spreading into the surrounding air. The final state contains vastly more microstates than the initial state. You experience this as a progression, a movement from order to disorder. But the universe itself does not know this progression. It simply allows all possible arrangements, with some vastly more probable than others. The sense of forward motion arises because the improbable states are rarely observed. This distinction is subtle but critical. Entropy provides an arrow, a direction in which sequences are overwhelmingly likely to unfold. It does not force a present to advance, nor does it impose a universal clock. The increase of disorder is compatible with a block universe in which all moments coexist. From that perspective, what you call the past contains lower entropy arrangements. What you call the future contains higher entropy arrangements, and nothing actually moves between them. Even the simplest equations of physics illustrate this neutrality. Newton's laws, Maxwell's equations, and the Schrödinger equation are all time-symmetric. They work equally well if you reverse the direction of time in the calculation. If the universe were fundamentally driven by time, these equations would need to favor one direction over the other. Instead, they only describe relationships between states. The apparent flow emerges when a statistical bias, entropy, produces overwhelmingly more configurations in one temporal orientation. Entropy is often invoked to justify the intuition that time must exist because events appear irreversible. But irreversibility is not a law. It is a pattern that emerges when vast numbers of particles interact. Break an egg in a laboratory with only a handful of particles, and the dynamics are reversible. Only when the number of particles reaches astronomical scales do the probabilities align with the experience of irreversible change. The arrow of time is therefore an emergent phenomenon, not a fundamental property. The implications extend to your perception of life itself. You remember the past because memories form in lower entropy configurations, and you anticipate the future because entropy increases. Your sense of flowing experience, the very feeling of now advancing, is bound to this statistical arrangement, not to the underlying structure of the universe. Time, in other words, may be nothing more than a pattern detected by observers embedded within a pre-existing four-dimensional block. This perspective explains why microscopic physics seems indifferent to time, while macroscopic phenomena insist upon it. At the human scale, entropy dominates. The world is messy. Order gives way to disorder. Your brain constructs a narrative of passing moments to make sense of these changes. But the narrative is imposed on a timeless substrate. The fundamental equations at all scales remain symmetric, reversible, and unchanging. Even the second law of thermodynamics, often treated as the hallmark of time's passage, does not require that the universe move in any moment-to-moment sense. It only specifies that in an ensemble of possible configurations, certain outcomes are overwhelmingly probable. Time appears to flow because your consciousness perceives sequences that reflect this bias. There is no cosmic clock behind the scenes, ticking relentlessly forward. The arrow of time, so central to daily experience, may ultimately be a byproduct of scale, statistics, and perception. It points convincingly in one direction, without implying that the universe itself is being carried along. Entropy, therefore, does not explain why there is time. It explains why you think you see it moving. And if the arrow of time is emergent rather than fundamental, then the most familiar sense of reality, past, present, and future marching in order, becomes a convenient illusion built atop a deeper, timeless foundation. The vanishing present moment. try to locate the present. The instant you attempt to measure it, it is already gone. A true moment with zero duration would contain no events at all. Every measurable slice of time must have some thickness, some extension into past and future. The present you believe you inhabit cannot be pinned down by any instrument. It may not exist in the way you assume. Your intuition insists on a sharp boundary between past and future, a precise now that separates what has happened from what is yet to happen. Every thought, every perception is assumed to occupy that boundary. But physics does not provide a mechanism for such a slice. There is no apparatus, no particle, no signal that can mark an exact present. The world continues independently of your attempt to identify it. The instant is never captured, only inferred. Consider what is required to define a moment. You must measure events occurring within it. Yet even the shortest interval, measurable in the laboratory, contains countless processes. Atoms vibrating, photons scattering, electrons shifting. No matter how finely you slice time, the present always contains activity that spans a duration at the smallest scales accessible to experiment. Uncertainty further blurs boundaries. Quantum mechanics ensures that no event can be localized to a perfect instant. Position, energy, and timing are all fundamentally constrained. Even at human scales, the problem persists. Light takes time to travel. Signals from your senses reach your brain with small delays. Your perception of now is slightly lagged, slightly smeared. Memory records events in sequences that overlap. The impression of a precise present is constructed, not received. Your mind stitches together multiple moments into what feels like a single, continuous instant. The present you inhabit is already a narrative, shaped by processing limits and temporal integration. Relativity adds another layer of complication. Different observers, moving relative to one another, disagree about what constitutes simultaneous. Two events that appear to occur together to you may occur in a different order for someone else. There is no single universal now. Any attempt to identify a shared present across space-time fails. The present cannot be a global fact. It is always local and relative, dependent on where and how you move. This realization undermines the core of your experience. You feel an advancing moment, a point that carries the world from past to future. But physics suggests that this feeling is an artifact of perspective. The universe contains all events within space-time, and your sense of the present is a path traced through that structure. It is a viewpoint, not a feature of reality itself. The world does not wait for you to arrive at a moment. It simply exists. The vanishing present also challenges how you think about causality. You naturally link cause and effect through successive moments, assuming that the present mediates between past and future. Yet if the present is not sharply defined, causation cannot depend on a moving slice of time. Instead, correlations exist across space-time. The order of events may appear clear from one perspective, but it is contingent upon location and motion. The present loses its central role in orchestrating the universe. Even attempts to define the present using entropy or other physical markers fail. Entropy provides direction, but it does not produce a boundary. Clocks provide measurement, but they only track changes in motion. The search for a precise now reveals only an extended interval or a relational ordering of events. The present, as an instantaneous point, eludes both observation and definition. Your experience of time is therefore provisional. What you call now is a window, not a point. The universe itself does not acknowledge it. It is a construction of perception, an emergent product of the mind interacting with a structure in which all events already reside. When you begin to accept this, the moment you thought you were living in, the now you assumed was fundamental, starts to disappear. It never existed in the way you imagined. It only seemed to, because your consciousness required a convenient perspective to navigate a timeless reality. Space and time become the same. Substance. Modern physics does not treat space and time as separate things. They merge into space-time, a single geometric entity. You move through this structure not only in space, but in time as well. From this perspective, time is not a river, but a dimension, similar to height or depth. And a dimension does not flow. It simply is. Your intuition resists this idea because space and time feel entirely different. You can move forward, backward, or sideways through space at will. You feel bound to a single, temporal direction, carried by what seems like an unstoppable current. Yet, relativity shows that this intuition is misleading. In the equations of physics, time is represented as another coordinate, intertwined with the three spatial coordinates. Motion through space affects motion through time, and vice versa. There is no universal distinction in the fundamental mathematics. The geometry of space-time dictates how objects move, how light travels, how clocks tick. Gravity is no longer a force pulling objects in space. It is the curvature of space-time itself. Massive objects bend the four-dimensional fabric, influencing the paths of planets, photons, and even time itself. Clocks in orbit tick faster or slower, because they follow different trajectories through this curved structure. Time bends because space bends. The two are inseparable. From this perspective, familiar metaphors like flowing time or marching moments begin to lose coherence. A river has a direction. It carries things along. It moves relative to its banks. But a dimension has no intrinsic direction. It does not advance. It is a coordinate within which positions can be located. Your experience of moving through time is analogous to moving along a path in space. The path exists as part of the geometry, and your perception traces it. Relativity also implies that the way you move through space changes how you move through time. An astronaut traveling near the speed of light experiences time more slowly relative to someone at rest. The faster you move through space, the less you move through the temporal dimension. This is not a metaphor. It is a measurable effect, confirmed by experiments with fast-moving particles and high-precision clocks. Time is not a separate river. It is a coordinate whose metric depends on motion through space-time. Even light, which moves at the maximum speed allowed in space, experiences time differently. From the perspective of a photon, the entire journey from emission to absorption is instantaneous. Past and future collapse along its path. For objects moving slower than light, temporal experience is stretched relative to their speed and gravity. The structure of space-time dictates how durations unfold, demonstrating that time is not fundamental as a separate entity. It is a relational property of the geometric continuum. This redefinition reshapes your understanding of causality and existence. Events are positioned in a four-dimensional landscape, not carried along by an independent current. Interactions occur at particular coordinates in space-time, not because a universal clock advances, but because the structure itself constrains the possibilities. Time, like space, is simply a dimension in which events are located. Its apparent flow is a byproduct of perspective, not a feature of reality. Even familiar concepts such as simultaneity dissolve under this framework. Two observers moving differently through space-time cannot agree on which events are simultaneous. What appears past, present, or future depends entirely on your trajectory through the four-dimensional manifold. Time loses its privileged role as the arbiter of reality, becoming just one axis among four, measured, curved, and relative. From this vantage, the universe no longer consists of objects moving through time. It consists of events embedded in space-time, fixed within the geometry. Your consciousness navigates this structure, producing the sensation of motion. But the motion itself is not fundamental. It is a perspective imposed on a timeless, four-dimensional reality. Time, space, and the geometry connecting them form a single substance. The river you imagine does not exist. There are only coordinates, distances, and paths. And once you understand this, the world you thought you inhabited, advancing moment by moment, begins to feel less like a flowing story and more like a static landscape in which your awareness traces a path. The equations that work without time. Some of the most advanced theories in physics, including attempts to unite quantum mechanics with gravity, can be written without any reference to time at all. In these frameworks, the universe is described as a static mathematical object. What you perceive as temporal evolution emerges only at larger scales. The deepest layer of reality appears timeless. This is a profound departure from everyday intuition. You live your life embedded in a continuous sequence of moments, each one following inevitably from the last. The idea that reality might exist as a complete structure without any flow or progression challenges the core of your experience. Yet in the mathematics of quantum gravity, time is not a necessary variable. The fundamental equations describe correlations and relationships, not sequences. Events exist, but the notion of before and after is absent at this level. One example comes from canonical quantum gravity, where the so-called Wheeler-DeWitt equation governs the wave function of the entire universe. Remarkably, this equation contains no time parameter. It encodes the probabilities of different configurations of matter and geometry, but it does not evolve in the way a wave function does in ordinary quantum mechanics. There is no ticking clock. There is no arrow. There is only the structure of all possible configurations considered together. Time, in this sense, is emergent, not fundamental. This shift forces a reconsideration of cause and effect. If the underlying laws do not include time, then what you perceive as one event triggering another may arise only from patterns within the static structure. The correlations between events, the chains of cause and effect, appear when large systems are examined at coarse scales. At the deepest level, there is no temporal ordering to enforce them. The universe is a block, and the connections you perceive are projections of your perspective moving through it. Even in simpler contexts, physics demonstrates that evolution can be an emergent concept. Consider statistical mechanics. At the level of individual particles, interactions are reversible, symmetric in time, and unchanging in fundamental rules. The passage of time emerges only when vast numbers of particles interact, producing a statistical arrow that your mind interprets as flow. Similarly, in quantum gravity, the vast structure of space-time can contain everything, while your perception isolates one trajectory and interprets it as motion through time. This approach is not merely theoretical. Attempts to reconcile general relativity with quantum mechanics encounter deep incompatibilities when time is treated as fundamental. Gravity curves space-time, mixing space and time, while quantum mechanics assumes a fixed temporal parameter to describe evolution. Removing time from the fundamental equations resolves some contradictions. It allows a description in which space-time itself is an emergent property, arising from relationships between elements of a timeless structure. From this perspective, what you call temporal evolution is more like a projection of the underlying geometry. Your consciousness interprets correlations between events as a flowing present, and larger-scale processes, like stars evolving or galaxies forming, give the impression of a dynamic universe. But the equations themselves need no flow. They work perfectly without it. This reveals an unsettling implication. The passage of time, the motion of moments, the progression from past to future, may exist only in the perception of observers embedded within the universe. On the fundamental level, reality may be a frozen structure in which all events coexist. The flow of time, the sensation that the universe advances, is not a law, but an emergent narrative, a pattern projected by your mind onto a timeless substrate. If the deepest equations function without time, then what you have always assumed to be fundamental, seconds, minutes, the steady march of moments, may be nothing more than a human-scale illusion. The universe, at its core, does not need a clock. It does not need a river. It simply is. And if the universe simply is, then your sense of moving through it may be just that: a perception, a path traced within a structure that has always existed in its entirety. Time, as you know it, is not the foundation of reality. It is a story your consciousness tells itself within a landscape that has no before and no after. Black holes and the freezing of time. Near a black hole, time slows to a crawl relative to distant observers. At the event horizon, it effectively stops altogether. If time can be halted by gravity, it cannot be an independent background. It must be something produced by physical conditions. A fundamental feature of reality should not be able to break down so completely. This phenomenon is not theoretical speculation. It is a direct consequence of Einstein's general relativity, confirmed through precise observations of objects orbiting dense masses. Clocks near massive bodies tick more slowly than clocks far away. In principle, If you approached the event horizon of a black hole, a distant observer would see your motion freeze, your seconds stretched toward infinity. From your own perspective, however, time would feel normal. Your experience would continue unbroken, even as the outside universe raced ahead. The implication is unsettling. Time is not uniform. It is malleable, tied intimately to the geometry and distribution of matter in the universe. What you have assumed to be a universal measure, ticking steadily forward everywhere, turns out to be local, contingent, and relational. Time depends on conditions rather than dictating them. If it can slow, stop, or stretch, it cannot serve as the independent backdrop for events that classical intuition assumes it to be. Consider the event horizon itself. It is a boundary beyond which nothing can return, not even light. For an external observer, objects approaching this horizon appear to freeze, suspended in time. Photons emitted from the falling object become increasingly red-shifted, fading into invisibility. Yet for the object itself, falling in freely, nothing peculiar happens. The apparent freezing is a feature of the space-time structure, not of the object's experience. Time is relative, dependent on position and motion within the gravitational field. It is not a universal stage that exists independently of matter and energy. This effect is magnified in extreme scenarios. Near supermassive black holes, the time dilation is enormous. A few hours near the event horizon could correspond to millions of years for distant observers. What you consider a brief instant could stretch across cosmic epochs. The apparent flow of time is entirely conditional, a product of gravitational curvature rather than a fundamental rhythm of reality. The universe does not require time to advance uniformly for physical processes to occur. It only requires the relationships between energy, mass, and geometry. Even theoretical considerations of black hole interiors reinforce this conclusion. Classical general relativity predicts that at the singularity, time as conventionally defined ceases to exist. Equations describing curvature diverge, and the familiar order of events breaks down. Whether singularities truly exist or are resolved by quantum gravity, the prediction itself shows that time cannot be fundamental in the way you intuitively assume. It is contingent, emergent, and dependent on context. Black holes also highlight the interplay between relativity and quantum mechanics. Hawking radiation, which allows black holes to emit energy, depends on quantum processes near the horizon. These processes are described without a global, universal time. They rely on local conditions and the structure of space-time. The combination of extreme gravity and quantum effects reinforces the picture that time is not a simple background, but a property emerging from physical circumstances. Your perception of time as steady, unyielding, and omnipresent is an illusion born from living far from these extremes. On Earth, variations are minuscule and imperceptible. But the universe contains regions where time literally behaves differently, where the concept of a flowing moment loses meaning. If a fundamental property can vary so dramatically depending on environment, it is unlikely to be fundamental at all. Time is not something the cosmos possesses independently. It is something the cosmos produces, locally and relationally, shaped by mass, energy, and geometry. Black holes make this painfully clear. They reveal that the steady march of seconds you take for granted is not universal. It is a contingent, emergent phenomenon. And if the progression of time can halt entirely under certain conditions, then what you call the present, the flow, and the passage of life is not a universal truth. It is a local experience, fragile and dependent, existing only where the conditions of space-time allow it to be perceived. The universe itself does not march forward. It simply exists, structured, curved, and timeless in ways that your everyday intuition cannot grasp the beginning without a before. You are told the universe began in the Big Bang. But asking what happened before the Big Bang may be meaningless. Many cosmological models suggest that time itself began with that event. If time can have an origin, then it cannot be the ultimate foundation of existence. Something deeper must give rise to it. The intuition that there must be something before is deeply ingrained. You naturally assume that every cause has a preceding cause, that every effect requires a prior moment. Yet the very structure of cosmology challenges this assumption. In standard Big Bang cosmology, the universe starts from a singularity or a state of extreme density and temperature. Space, matter, energy, and time itself emerge from this initial state. To ask what came before is to ask for a temporal reference that does not exist. Time itself is born with the expansion of space-time. This has profound implications. If time began, it is not an eternal backdrop. It does not exist independently of physical reality. It is contingent, emerging from the structure and dynamics of the universe. Just as the curvature of space is produced by matter and energy, time may be produced by the universe itself, arising only under specific conditions. The notion of an infinite temporal flow is no longer guaranteed. Past, like future, is bounded. Modern cosmology supports this conclusion through observations of the cosmic microwave background and the large-scale structure of the universe. These remnants of the early universe show a uniformity and coherence that imply a beginning in which space-time itself was created. Inflationary models suggest that space expanded exponentially, carrying time along with it. Even if the universe exists forever in some abstract sense, the meaningful time we experience is finite, stretching only as far as the Big Bang allows. Quantum cosmology complicates the picture further. Approaches that attempt to describe the universe using quantum mechanics often replace the classical singularity with a quantum bounce or a probabilistic wave function of the cosmos. In such frameworks, the universe may exist in a timeless, static configuration at the most fundamental level. What appears as a beginning, the Big Bang, is a transition from a timeless state into one where space-time, and therefore temporal experience, emerges. Before the Big Bang is not merely unknown, it may be undefined. This challenges your most basic sense of causality. You are accustomed to tracing events backward, following chains of cause to prior moments. If time itself starts at a boundary, then there is no chain to follow beyond that boundary. Causes and effects depend on temporal relations. Without time, those relations cannot exist. The universe, at its origin, may be a structure without temporal order, giving rise to what we call before and after only as an emergent property. Philosophically, this undermines the idea of time as fundamental. Something must underpin its existence, a deeper structure from which temporal relations arise. It could be a geometric feature of a higher dimensional manifold, a static quantum state, or a pattern of correlations within a timeless mathematical object. Whatever it is not time itself, because time cannot exist prior to its own emergence. Even the language of beginnings becomes precarious. The Big Bang evokes the image of an explosion in a pre-existing temporal frame. But no such frame exists. There is no before in which the universe ignites. There is only the emergence of space-time and the unfolding of events measured relative to that emergence. Every moment you experience is built atop this temporal foundation, yet the foundation itself is not temporal. If time has a beginning, it is contingent. It is a property arising from physical reality, not a container for it. The universe requires something deeper to exist. The ultimate fabric is timeless. And if the foundation of everything is timeless, then the flow you call time, the moments you navigate, and the chains of cause and effect are all emergent phenomena, built atop a substrate that lies beyond past and future alike. The Big Bang, then, is not merely the beginning of matter and energy. It is the origin of time itself. And if time can have an origin, the ultimate reality is something stranger and more fundamental than the steady march of seconds you have always assumed. The future already written in physics. The fundamental laws of nature are deterministic at their core. Given complete information about the universe, those laws describe all moments at once. From that viewpoint, the future is not being created. It already exists as part of the structure. Your feeling of moving toward it may be nothing more than limited knowledge unfolding. Classical physics makes this clear. Newton's equations, applied to a complete configuration of matter and motion, can, in principle, predict all future states. Laplace imagined a hypothetical intelligence that, knowing the position and velocity of every particle, could calculate the past and future with perfect accuracy. Determinism implies that the universe is not advancing into the unknown. It is fully mapped, its outcomes encoded in the present structure. Even in systems that appear chaotic, determinism persists. Sensitive dependence on initial conditions creates unpredictability for practical purposes, but it does not remove the underlying determinism. The unpredictability you experience is a consequence of incomplete information, not the creation of the future itself. In this sense, what you perceive as novelty or choice may be an emergent property of your perspective within a fully defined structure. Relativity reinforces this picture. In the block universe, all events, past, present, and future, exist simultaneously within space-time. The sequence you perceive is a path traced by consciousness through a fixed geometry. From the outside, there is no creation, no unfolding, no becoming. Each future event is already situated at its coordinates, determined by the configuration of matter, energy, and space-time geometry. Your sense of approaching it is entirely local and relative. Quantum mechanics introduces apparent indeterminacy. But even here, the picture is subtle. The fundamental wave function evolves deterministically according to the Schrödinger equation. Probabilities arise only when measurements are made, and in interpretations such as the many worlds formulation, every possible outcome exists simultaneously. From the perspective of the entire wave function, nothing is being created. Every branch of every event is already contained in the structure. Your experience of one outcome unfolding is a reflection of limited access to the full set of possibilities. Entropy and thermodynamics also contribute to the illusion of a future being created. You perceive a flow from past to future because disorder tends to increase, and your memory encodes information in a particular temporal direction. Yet the statistical arrow of time does not generate novelty. It organizes it. The rising entropy structures sequences of events in ways that give the impression of a moving present. But the underlying physical relationships are already fixed. The directionality is emergent, not fundamental. This perspective changes the meaning of causality. Cause and effect are no longer rules that push reality forward. They are constraints embedded in the structure of events. The effect already exists where it will exist. The cause already exists where it did. Your experience of one triggering the other arises from your perspective traveling along a particular path in space-time. Time's arrow, like movement through space, becomes a relative feature of observation rather than a universal flow. Your sense of free will and anticipation is also reframed. You believe that you are approaching the future moment by moment, that decisions shape what is to come. Yet physics suggests that what you call the future is already written in the relationships between events. The apparent openness is a limitation of perception, a consequence of partial knowledge of the vast structure in which all possibilities are already embedded. Even large-scale phenomena, from planetary orbits to stellar evolution, conform to this view. Every trajectory, every collapse, every formation is encoded within the laws. The universe is a complete tapestry, not a film being projected. Your experience of moving forward through it is a perspective within the tapestry, not an indication that the universe itself advances. If the future is already written, then the passage of time is not a process of creation. It is a perception of unfolding knowledge, a sequential awareness of what already exists. What you call the next moment is not arriving. It is simply the next coordinate your consciousness traces through a universe that contains all moments simultaneously. The universe, in its deepest sense, is timeless in the way it organizes outcomes. Your feeling of approaching the future is only a reflection of limited access to a structure that has always existed in its entirety. Time, causality, and the unfolding of events are features of perspective, not of the fundamental fabric of reality. Memory as a construction of time. You rely on memory to confirm that time passes. But memories are physical patterns stored in a brain, subject to error and distortion. They are records existing in the present, not windows into a moving past. Without memory, your sense of duration would collapse. The flow of time may be built from biology rather than physics. When you recall an event, what you access is a network of neurons encoding chemical and electrical states. These states correspond to structures and patterns formed in the brain, not to moments that continue to exist out there in the past. A memory is entirely a present phenomenon, a static configuration of matter and energy that your consciousness interprets as a record of something gone. It is a reconstruction, not a playback, and its reliability depends on the stability of the neural patterns themselves. Memory's dependence on the present explains why our perception of temporal flow is inherently subjective. You feel that moments succeed one another because your brain is constantly updating, comparing new sensory input with stored patterns. This creates the illusion of a river of time. But the river exists only in the activity of your mind. Outside your brain, physics describes correlations between events, not their sequential experience. The universe does not require a mind to advance. It only contains relationships between states. Consider how memory can fail. Events can be misremembered, combined, or forgotten entirely. Yet the physical structure of the universe, the evolution of stars, the orbits of planets, the decay of particles, continues independently. The world does not slow, accelerate, or vanish when memories fade. Memory is not a fundamental witness to time. It is a mechanism through which temporal order is perceived. The flow of time that you trust is intimately tied to the limitations and functions of your neural architecture. Even at the scale of perception, the brain smooths over discontinuities. Sensory input is processed with slight delays. The integration of events creates continuity where none exists objectively. The now you experience is constructed from overlapping windows of perception, each containing traces of recent inputs. Memory links these windows together, generating the sensation of an ongoing present. Without this integration, your experience would fragment into disconnected slices, and the apparent continuity of time would dissolve. Memory also imposes directionality on your perception. You remember past events, but do not remember the future. This asymmetry reinforces the arrow of time in your mind, even if physics itself is largely indifferent to direction at the fundamental level. The increase of entropy, which biases the formation of memories toward one temporal orientation, provides the scaffolding for your sense of forward flow. Yet it does not create time itself. Memory interprets patterns, giving the impression of a moving present. The biological construction of time explains why different creatures experience temporality differently. Some animals perceive events on timescales that seem rapid to us. Others experience them as slow. The flow of time is not absolute. It is filtered through the processing mechanisms of the observer. Consciousness constructs a temporal narrative from available information, weaving sensory input and memory into a coherent sequence. The passage you feel is an emergent property of this narrative. Even in humans, memory is malleable. Memories can be altered by suggestion, imagination, or repetition. The apparent continuity of personal history depends on the stability of these neural records. When memories fail, so too does the subjective perception of elapsed time. The brain, not the universe, dictates what you experience as duration. This perspective reframes the meaning of past and future. The past exists only as encoded patterns in your present mind. The future exists only as anticipation or prediction based on current conditions. Both are mental constructs superimposed on a four-dimensional structure in which events already reside. The flow of time, then, may be less a feature of reality than a product of biology, a mechanism by which conscious beings navigate a static, timeless universe. If memory constructs your sense of duration, the moments you experience are not carried by a universal river. They are stitched together from patterns your mind interprets as order. Time, as you feel it, may be a psychological artifact emerging entirely from the way brains process, store, and recall information. Your life, your history, and your perception of moving through reality could be entirely built atop this biological framework, projected onto a universe that itself exists timelessly. Consciousness and the manufactured. Now neuroscience shows that your experience of the present is assembled from fragments processed at different speeds. What feels like a single instant is a carefully edited illusion created by the brain. If the present moment is constructed, then your most direct evidence for flowing time becomes unreliable. Sensory signals do not arrive simultaneously. Light, sound, and touch travel at different speeds and are processed by different neural pathways. The brain reconciles these inputs by integrating them over short intervals, creating the impression of simultaneity. What you perceive as a single, coherent now is in fact a composite of events that may have occurred milliseconds apart. The continuity of experience, the seamless present you trust, is therefore a product of biological processing rather than an objective feature of the universe. Experiments in neuroscience make this construction visible. In studies where stimuli are deliberately delayed in one sensory channel, subjects perceive events in ways that contradict actual timing. The brain fills gaps, reorders signals, and synthesizes a coherent moment. Your perception does not reflect raw temporal order. It reflects the brain's interpretation, optimized for coherence and survival. The present you inhabit is edited, stabilized, and sometimes fabricated entirely. Memory plays a complementary role. Immediate memory bridges tiny intervals, connecting fragments into what feels like a flowing present. Without this short-term integration, perception would be fragmented, and the experience of continuity would vanish. The present is therefore not merely what is happening. It is what your brain constructs from both current sensory input and traces of immediately preceding events. Time, in this sense, is a mental artifact. This construction extends to predictive processing. The brain anticipates incoming information to compensate for neural delays. It generates expectations, fills in missing data, and even preempts events slightly before sensory input completes. Your sense of being in the now is therefore influenced by both what has just occurred and what your brain predicts will occur. The present is a negotiation between past, present, and projected future, compressed into the illusion of a single instant. Relativity and neuroscience intersect here in unexpected ways. Relativity shows that simultaneity is relative. Different observers cannot agree on which events are simultaneous. Neuroscience shows that your own brain must decide what is simultaneous at any given moment. The now is relative both to your position in space-time and to the internal processing of your consciousness. There is no universal present. What feels immediate is always a local, constructed phenomenon. Even decision-making illustrates this manufactured present. Neural activity, predicting choices, can be detected before subjects report conscious awareness. The brain initiates action before you are aware of it, creating the illusion that decisions arise in the flowing present. The temporal order of intention, perception, and action is smeared. The present is not a point of creation. It is a constructed interface between cognition and reality. This understanding reframes the arrow of time you experience. It is not dictated by the universe. It is projected by consciousness. The forward movement of seconds is a byproduct of how your mind integrates information. Without the brain's editing, the past and future would not cohere into a seamless now. Time, as directly felt, may be entirely emergent from neurobiological processes, not from fundamental physics. Your perception of change, continuity, and flow is therefore provisional. The universe itself contains events, correlations, and structures, but it provides no intrinsic mechanism for a moving present. The sensation of the present is a product of perspective built from fragments, delays, predictions, and memory. The more closely you examine the brain's role, the less convincing the argument for a fundamental flowing time becomes. If consciousness manufactures the present, then the evidence for temporal flow, the thing you experience most directly and intimately, is unreliable. What you believe is the immediate, advancing now is only a construction, an emergent property of a brain navigating a timeless landscape. The now is not given by the universe. It is imposed by your mind. And if the most direct evidence of flow is a fabrication, then the river of time you feel may never have existed at all. What you experience as movement from moment to moment is simply the brain tracing a path through a universe in which all moments already exist, fixed and timeless. Reversible laws in an irreversible world. Every fundamental interaction known to physics works equally well forward and backward. Nothing in the equations demands a preferred direction. The irreversibility you witness arises from large collections of particles, not from time itself. This suggests that temporal flow is not written into the fabric of nature. At the microscopic level, the laws governing particles are time symmetric. Newton's equations of motion, Maxwell's equations for electromagnetism, and the Schrödinger equation in quantum mechanics all operate identically if time is reversed. A collision between two atoms would be just as valid if the velocities were inverted and the sequence ran backward. The underlying dynamics do not prescribe a past or a future. They only describe correlations between states. Yet, at macroscopic scales, you observe irreversibility everywhere. Ice melts, smoke disperses, stars exhaust their fuel. The forward progression of entropy dominates your perception of events. This asymmetry is not a consequence of the fundamental laws, but emerges statistically from the vast number of interacting particles. Systems overwhelmingly evolve toward configurations that are more probable, creating the appearance of time marching forward. But probability, not physics, is doing the work. The contrast between microscopic reversibility and macroscopic irreversibility is subtle but profound. On one hand, the rules allow motion and interaction without preference. On the other, collections of countless particles produce outcomes that almost never revert spontaneously. You perceive a world in which causes precede effects and moments advance. Physics, however, reveals that these impressions are emergent, constructed from overwhelming statistical bias rather than dictated by the universe itself. This distinction is amplified in thermodynamics. The second law, which asserts that entropy increases in isolated systems, is often cited as proof of the arrow of time. Yet, the law is not absolute. It is statistical. It is overwhelmingly unlikely that a highly disordered system will spontaneously return to a more ordered state, but not impossible. In principle, Microscopic reversibility allows a reversal, even if probability renders it unobservable. Time's forward motion is not guaranteed by the fabric of reality. It arises from patterns formed by aggregates of particles. Quantum mechanics presents a similar picture. Individual processes, such as the evolution of a particle's wave function, are time-symmetric. Measurements introduce apparent randomness and irreversibility, but the underlying equations themselves do not require a direction. What you interpret as time flowing is the unfolding of correlations within a particular branch of possibilities, not the imposition of a temporal substrate. The irreversibility of experience, then, is a feature of context, not law. Even in classical physics, thought experiments illustrate the tension. If you were able to reverse the velocities of all particles in a room, the room would return to its previous state. The shattered glass would reassemble. Smoke would reconverge into a flame. The laws permit it, but in practice, it never occurs. Your perception of causality and temporal flow is constructed on the improbability of such reversals, not on fundamental rules. The implication is that the arrow of time is conditional, not universal. It emerges from large-scale arrangements, from the statistical properties of ensembles, from memory and consciousness interpreting correlations. The universe, at its most fundamental level, is indifferent to before and after. There is no flow imposed on particles, fields, or space-time itself. What you experience as moving forward is a feature of perception applied to a structure in which all states coexist. This insight forces a reconsideration of irreversibility. The world may feel asymmetric, but the microscopic rules remain symmetric. The universe does not carry time forward. It only contains relationships that appear to you as sequences. The passage of moments, the sensation of events advancing, is not a law of nature, but an emergent property of scale, statistics, and consciousness interacting with a timeless substrate. Temporal flow, so central to your experience, may therefore be an illusion. The universe itself does not care about forward or backward. It only contains events and correlations in which you perceive sequence because of your embedded perspective. Reversibility, at the fundamental level, exposes the fragility of the river of time you trust. The flow you feel may not exist outside your own interpretation of the patterns you inhabit. Multiple times for multiple observers. Two people traveling different paths through space-time will age by different amounts. Each carries their own personal measure of duration. There is no single clock governing reality. If time were truly fundamental, it would not fracture into so many conflicting versions. Einstein's theory of relativity makes this undeniable. Consider two twins, one remaining on Earth, the other traveling at near light speed on a starship. When the traveler returns, decades may have passed on Earth, while only a few years have elapsed for the traveler. Both measures of time are correct within their own frames of reference. Time is not universal. It is relative to motion and gravitational influence. What you consider a second is not guaranteed to match anyone else's second in a different frame. The relativity of simultaneity extends this fracture. Events that appear simultaneous to you may occur at different moments for someone moving relative to you. There is no absolute now that stretches across the cosmos. Each observer traces a distinct path through space-time, experiencing duration according to their trajectory. The universe contains multiple temporal perspectives, each internally consistent, but incompatible with the others. Gravity compounds the effect. Clocks closer to massive objects tick more slowly, relative to distant clocks. Astronauts aboard orbiting satellites experience time slightly faster than people on the surface, requiring corrections to GPS systems to maintain accuracy. Even at everyday scales, these differences are real, measurable, and unavoidable. The fact that time varies depending on position and motion demonstrates that it is not an immutable backdrop. It is a relational property, emerging from the structure of space-time itself. This multiplicity undermines the idea of a single, global present. If there were a universal time, all observers would agree on the sequencing and duration of events. Relativity shows that this is impossible. Each observer carries a private timeline, a personal history and future shaped by their motion through the four-dimensional manifold. Time is no longer a universal stage. It is a coordinate measured along particular paths, dependent on perspective and context. Even mundane experiences illustrate this subtly. Traveling long distances on Earth at high speed produces measurable, though tiny, differences in elapsed time. Atomic clocks flown around the globe have recorded nanoseconds of discrepancy compared to stationary clocks. These discrepancies are small, but they are real. They confirm that time is not absolute, and that your perception of a consistent flow is a local convenience, not a universal law. From this perspective, the notion of a single, ordered sequence of events dissolves. What you consider the past, present, and future depends entirely on your motion and position. Two observers can disagree on the order of events, each correct within their own frame. Temporal relations are not imposed externally. They are intrinsic to the observer's paths through space-time. Duration and sequence are therefore context-dependent, not absolute. This raises deeper implications for causality and experience. If time is fragmented across observers, the concept of a universal cause leading to a universal effect becomes ambiguous. Each trajectory through space-time defines its own sequence of causes and consequences. Events do not occur simultaneously for everyone. What is after for one may be before for another. The universe does not carry a single temporal current. Instead, it accommodates multiple, overlapping flows. Ultimately, the relativity of time shows that what you take for granted, seconds, minutes, hours, is provisional. It is tied to your particular motion and the gravitational environment you inhabit. Time is not an independent property of reality. It is a measure that emerges from the geometry of space-time and the observer's path through it. Each observer carries their own clock, their own duration, their own experience of the sequence of events. If time can fracture in this way, it cannot be fundamental. Its seeming universality is an illusion. The river of moments you inhabit is local, contingent, and observer-dependent. Across the cosmos, every trajectory carries its own measure, and the flow you feel is only one among many, a product of your motion through a timeless, four-dimensional structure. The universe, described as information. Some modern theories propose that the universe is fundamentally made of information. In these models, physical reality emerges from relationships between data, not from events unfolding in time. Information structures do not require a ticking clock. They exist all at once. Consider how this perspective reframes the familiar notion of time. If reality is a network of information, then what you perceive as change or motion is a pattern within a pre-existing structure, not a process flowing from past to future. The before and after you experience are emergent consequences of correlations within this informational fabric, not evidence of a fundamental temporal progression. Time, in this view, is a derived concept, arising only when observers within the system interpret data sequentially. Quantum mechanics already hints at this. The quantum state of a system encodes all possible outcomes and their probabilities, independent of temporal evolution in the classical sense. When a measurement occurs, what seems like the next moment is actually the selection of a branch from an already encoded set of possibilities. The underlying information structure does not wait for time to unfold. It contains all potential configurations simultaneously. Your perception of sequence is simply a path traced through these possibilities. Black holes further illustrate the informational perspective. Theoretical work in black hole thermodynamics, including the holographic principle, suggests that the information describing the interior of a black hole is encoded on its boundary, on a two-dimensional surface. The universe itself can store information without reference to time. What you think of as dynamic evolution may be only the manifestation of relationships between informational states, projected into a temporal perspective for observers embedded within the system. Even cosmology supports this abstraction. The large-scale structure of the universe, the distribution of galaxies, dark matter, and radiation, can be seen as patterns of relational information. Expansion and evolution, while measurable, may be emergent phenomena arising from the way these informational relationships are interpreted by observers constrained to experience them sequentially. The universe does not require a temporal substrate to exist. It only requires a network of correlations that can manifest patterns consistent with physical laws. From this vantage point, causality and sequence are no longer fundamental. They are constraints encoded in the informational structure, which define consistent relationships between states. The arrow of time, entropy, and observed irreversibility arise because observers experience correlations along specific trajectories. The information exists entirely. What you perceive as temporal flow is the extraction of order from a static network. Past, present, and future are embedded in the same structure, encoded in ways that can only be traced by consciousness moving through it. Neuroscience intersects with this perspective. Memory, perception, and anticipation can be seen as processes that interpret and organize information. Your experience of a flowing present is constructed from the relational patterns encoded in the brain. The information theoretic universe provides the substrate. Consciousness organizes it into a sequence. Time becomes a derived narrative, emergent from informational relationships rather than imposed externally. This framework also dissolves traditional paradoxes about beginnings and endings. If the universe is a structure of information, the Big Bang is not necessarily a temporal origin, but a boundary condition within the informational network. The future is not coming into being. It is already encoded in the structure. Observers experience it progressively because their cognition samples information sequentially. The universe does not advance. The observer interprets. Even entropy, often considered the guarantor of time's arrow, can be recast in informational terms. High entropy states are simply configurations with more possible microstates, more informational arrangements. The increase of entropy is a statistical tendency in relational data. not a directive from an external temporal flow. Time emerges from how these informational patterns are parsed, not from any intrinsic progression. If the universe is fundamentally informational, then the notion of time as a universal, flowing medium becomes unnecessary. The cosmos exists as a vast, structured network of relationships, complete and self-consistent. Your perception of change, motion, and passage is a product of your interaction with that structure. What you call temporal flow is a cognitive mapping of static information, an emergent feature projected onto a universe that exists timelessly in full. Experiments that defy temporal order. Quantum laboratories have created situations where it is impossible to say which event happened first. The results remain consistent, even when temporal sequence is deliberately scrambled. Nature seems perfectly comfortable operating without a fixed order of moments. Consider entangled particles. 2 photons can be generated in a single event and then sent to distant detectors. When measurements are made, the outcomes exhibit correlations that cannot be explained by any local signal traveling between them. What is striking is that the ordering of these measurements can be altered in such a way that neither can be said to have occurred first. The correlations remain intact. The universe enforces consistency, yet makes no reference to a linear temporal sequence. Other experiments go further. Quantum switch experiments place operations in superpositions of different orders. 2 actions can be applied to a system such that it is fundamentally undefined whether A occurred before B or B before A. The results still match the predictions of quantum theory. The sequence of events, so essential to classical intuition, is not required for the laws of nature to function. Time, in these cases, is not a precondition for physical outcomes. It is irrelevant. These findings challenge the core assumption that cause must precede effect. At the quantum level, events are defined by their relationships, not by temporal succession. Correlations are real, predictable, and measurable, yet they do not depend on a global clock. Observables do not need a timeline to retain coherence. Physics operates in terms of structure and pattern, rather than flowing moments. The direction and ordering that you rely on are properties of your perception, not of the underlying processes. Even in practical applications, these effects are measurable. Photons passing through different pathways in an interferometer can produce interference patterns independent of the order of traversal. Experiments demonstrate that outcomes can be probabilistically determined without reference to which action occurred first. The concept of a before and after becomes a convenience, not a necessity. Temporal order is a human imposition on phenomena that are fundamentally order agnostic. This perspective reframes causality itself. Traditional logic assumes a linear chain. Cause leads to effect. Effect produces the next cause, and so on. In the quantum experiments, the correlations between events exist without requiring such a chain. Events are related, but their sequencing is flexible, mutable, and in some cases undefined. Cause and effect emerge only at scales where many particles and interactions average out to produce a perceived temporal order. At the fundamental level, these relationships exist in a static structure, indifferent to the direction you assume. Relativity complicates the picture further. Observers in relative motion can disagree on the order of spatially separated events. Quantum experiments that scramble temporal sequence amplify this relativity. Not only is there no universal now, but the sequence of operations itself may lack objective meaning. Physical laws remain intact. Consistency is maintained. The universe accommodates multiple sequences simultaneously, without privileging any of them. Entropy and classical thermodynamics provide only an apparent order. The macroscopic arrow of time emerges statistically from the overwhelmingly probable outcomes of large ensembles. At the microscopic level, experiments show that nature does not rely on this arrow to function. Whether particles act in one order or another, the results conform to physical law. Time's flow is not a prerequisite for predictability or stability. The implication is profound. Your experience of sequential events, of before and after, is a perceptual framework applied to phenomena that are fundamentally sequence-independent. The universe itself does not need moments to occur in a particular order. It only requires relational consistency. The progression you feel is a narrative constructed by consciousness, interpreting correlations. If experiments can scramble temporal order without altering outcomes, then the concept of time as a fundamental medium is called into question. Time is not the scaffolding upon which events hang. It is a feature of perspective, a tool of cognition, and an emergent property of complex systems. At the deepest levels, nature operates without the river you take for granted. Moments do not flow. They coexist, correlated, timeless, and unconcerned with the order you perceive. Timeless mathematics, beneath reality. Mathematics, the language of physics, exists outside of time. Equations do not age or change. If the universe is ultimately described by mathematical structure, then its deepest layer may be as timeless as the formulas that define it. What you experience could be a dynamic appearance resting on a static foundation. Consider how physical laws are expressed. Newton's equations, Maxwell's equations, Einstein's field equations, all are timeless statements. They encode relationships between quantities, constraints that do not themselves evolve. A gravitational equation does not tick forward. It simply relates masses and distances. It is true whether the universe existed yesterday, today, or a billion years from now. The reality it describes can appear dynamic, but the underlying mathematical structure is eternal and unchanging. Even quantum mechanics operates on timeless foundations. The Schrödinger equation dictates how the wave function evolves, yet the equation itself is immutable. Its predictions depend on boundary conditions and initial states, but the form of the law is independent of when it is applied. Probabilities unfold, correlations manifest, but these are patterns emerging within the framework, not creation ex nihilo. The mathematics remains constant, outside the flow of moments. Modern physics increasingly interprets reality in terms of structures and relationships that are purely mathematical. String theory, loop, quantum gravity, and other approaches attempt to model the universe as a network of geometric and algebraic relations. These structures do not require time to exist. They are defined by internal consistency, symmetry, and logic. Dynamics and motion emerge as a perspective within the structure, not as fundamental features. Time appears as a parameter or emergent property rather than a prerequisite. This perspective challenges your intuition about causality and becoming. You perceive events unfolding, consequences following causes, and moments arriving sequentially. Yet if the universe rests upon timeless, mathematical truths, what you call happening is a way of sampling or navigating a static landscape. The equations exist in their entirety. All possibilities are encoded. Your experience of temporal progression is only a traversal of a pre-existing structure. Even the constants of nature, gravitational strength, the speed of light, Planck's constant, illustrate timelessness. They do not vary with the flow of seconds. They are embedded in the mathematical relations that govern interactions. If these constants and the laws they support define the architecture of reality, then the universe is a fixed object in the space of possible configurations. Change, evolution, and time are phenomena emergent from that object, not constituents of it. Cosmology reinforces this interpretation. The initial conditions of the universe, the evolution of galaxies, and the emergence of complexity can all be described in terms of constraints and probabilities embedded in mathematical relationships. Whether these events occur sequentially or are viewed as part of a four-dimensional block, The underlying mathematical structure does not depend on a moving present. The equations themselves are timeless. They encode the universe as it is, wasanbai, and could be. This view aligns with approaches in quantum gravity that attempt to describe a pre-space-time reality. Before space-time emerges, before causality and sequence, the fundamental description may be a purely mathematical object, a network of relations that is complete and static. Temporal notions arise only when observers emerge within the structure, sampling and interpreting correlations as sequences. Time is not baked into the foundations. It is a projection layered atop them. Your subjective experience reinforces the illusion. Consciousness interprets sensory input sequentially, constructs memory, and imposes order. This gives the impression of a flowing time, yet the substrate beneath your experience may be entirely static. Change is perceived, not fundamental. Events appear to happen, but into reality. They exist timelessly within the mathematical framework that defines possible realities. If mathematics is the ultimate fabric, then the universe is timeless at its deepest layer. The moments you inhabit, the flow you sense, the arrow of cause and effect, all are emergent patterns on a foundation that does not move. What you experience is dynamic only because your consciousness navigates it that way. At the base level, there is no past, no present, no future. There is only eternal mathematical structure, and your perception of time is a pathway traced through it. The self that moves through nothing. You feel like a traveler advancing from past to future, yet physics describes no mechanism for this journey. There is only a series of brain states laid out in space-time. The moving self may be another useful illusion, a narrative created to organize experience. When you reflect on your own consciousness, it appears as though there is an I moving through time. You remember the past, anticipate the future, and experience the present as the point of passage. Yet these experiences are patterns of neural activity occurring in your brain, embedded within the four-dimensional structure of space-time. Each brain state exists at a particular coordinate, complete and fixed. The sensation of motion through these states arises from their sequential interpretation by consciousness, not from an objective movement in time. Neuroscience confirms that what you perceive as continuity is assembled from discrete fragments. Neural firing, chemical signaling, and synaptic changes occur in sequences, but they do not carry themselves forward. Your brain constructs a narrative, linking successive states to give the impression of a traveling self. The moment-to-moment awareness of experience is therefore an emergent property of pattern recognition. a bridge between static states. The self that moves is a story your mind tells itself to maintain coherence. Relativity and anomaly, the block universe, reinforce this picture. In four-dimensional spacetime, every event, including every brain state, exists in a fixed location. There is no external mechanism propelling consciousness from one coordinate to another. Your sense of movement arises entirely from the organization of states within the structure. The brain's temporal markers, memory, and sensory integration produce the subjective flow of self, but the universe itself does not carry you along. Even quantum processes contribute to this illusion. The probabilistic unfolding of events at microscopic scales gives rise to experiences you interpret as choice and agency. Yet the superposition of possibilities exists in the structure. Only your perspective traces a definite path. What you consider your life unfolding is a selection within a pre-existing set of correlations. The moving self is therefore an emergent phenomenon, dependent on perspective, not an independent entity navigating a dynamic time. Psychology adds another layer. Humans construct coherent identity by sequencing experiences into a continuous narrative. The self is defined by memory, anticipation, and attention, which together generate the impression of temporal travel. When memories are disrupted or perception altered, this continuity can fragment, demonstrating that the sense of moving through time is a cognitive artifact rather than a reflection of physical reality. Yourself is a vector through interpreted data, not a passenger on a flowing timeline. Consider thought experiments. If you were removed from perception, if awareness ceased, nothing in the universe would carry yourself along. Your past and future states remain in space-time, unchanged. The continuity you feel is entirely tied to observation. The moving self exists only as a construct, arising from the brain mapping correlations in a sequence that it interprets as progression. This perspective reshapes causality as experienced by the self. Actions appear to flow outward from intention. Decisions feel like events propagating forward, and consequences seem to arrive in sequence. Yet, in the underlying physics, all states coexist. Cause and effect are embedded relationships in space-time, not active forces moving you along a timeline. Your consciousness interprets structure as narrative, generating the illusion of agency in time. The emergent self is therefore a bridge between perception and a static universe. It organizes experience, generates a sense of continuity, and sustains the illusion of moving through moments. Without this construction, each brain state would be isolated in space-time, and there would be no experience of becoming. If the self is not moving, then your most intimate sense of temporal passage, the feeling of existing in a present that advances, is unreliable. The universe does not transport you. It only contains coordinates. What you inhabit as now is a perspective tracing patterns through a fixed structure. The traveler you perceive yourself to be is a cognitive projection, navigating nothing, yet producing the profound illusion of movement through time. When time stops explaining anything, as theories grow more precise, time becomes less necessary. Phenomena once explained by temporal processes are increasingly described by timeless relationships. Each scientific advance reduces the role of the flowing clock you instinctively trust. Consider classical mechanics. Newton's laws once framed the universe in terms of objects moving through space over time. Acceleration, velocity, and momentum were all defined with respect to seconds and minutes. Yet when these laws are expressed in more abstract formulations, Lagrangian or Hamiltonian mechanics, they describe the relationships between configurations, energy, and action without requiring an independent flow of time. Time becomes a parameter, a convenient label for ordering states, not a fundamental necessity for the equations themselves. Quantum mechanics amplifies this trend. The Schrödinger equation governs the evolution of a wave function, but the formalism can be expressed in terms of correlations between observables rather than as a temporal progression. Probabilities, entanglement, and superposition describe static structures of potential outcomes. The apparent evolution that you perceive emerges from the perspective of an observer sampling these correlations sequentially. Time is no longer a primary ingredient. It is a derivative of relationships within a more fundamental, timeless framework. Even cosmology presents examples where time loses explanatory power. The Big Bang marks the origin of the universe as we perceive it. But many models of quantum gravity suggest that time itself may not exist at the Planck scale. The earliest moments are described by boundary conditions and geometric constraints rather than sequences of seconds. The expansion of space, the formation of matter, and the emergence of large-scale structure can all be framed in terms of correlations and constraints that exist timelessly. Temporal language becomes a convenience, not a requirement. Thermodynamics and entropy, long considered the grounding for the arrow of time, are increasingly understood as statistical patterns rather than fundamental directions. Entropy explains why you perceive processes as irreversible, but the underlying microscopic laws remain reversible. the directionality of time is emergent, arising from the aggregation of states and the perspective of observers embedded within them. Time does not enforce change. It is inferred from it. Even relativity undermines the explanatory role of time. Special relativity shows that there is no universal present. Each observer experiences duration differently, and simultaneity is relative. General relativity reveals that gravity warps the flow of clocks, stretching and compressing intervals. What you might have thought of as uniform, universal time is replaced by local, context-dependent measures. The flowing river of time you rely on ceases to provide a coherent framework for the cosmos. In more recent theoretical developments, such as attempts to reconcile quantum mechanics and gravity, time often disappears entirely from the fundamental equations. Approaches like canonical quantum gravity describe the universe as a static structure of constraints and relations. The evolution you perceive is an emergent phenomenon projected by observers who sample and interpret the structure. Time is stripped of its explanatory authority. The universe functions without it. Even everyday phenomena, which once seemed inseparable from temporal concepts, can be recast in timeless terms. Chemical reactions, phase transitions, and particle interactions can be described as shifts between states in a configuration space. The sequence you observe is meaningful only relative to other states and observers. Time is a lens through which you interpret changes, not a fundamental ingredient. If time is no longer necessary to describe motion, causality, or evolution, its explanatory power diminishes. The seconds, minutes, and hours you experience may be entirely emergent, a cognitive framework imposed on a structure that does not require them. Each advance in physics erodes the necessity of the flowing clock, revealing that the universe may be fully described by static relationships and timeless constraints. The more precisely science uncovers the foundations of reality, the less compelling the idea of time as a fundamental property becomes. Processes you thought demanded a river of moments can be understood as correlations, patterns, and relationships. The flowing present you trust may be nothing more than a projection, a construct of consciousness imposed on a universe that functions perfectly without it. Time, once indispensable to explanation, becomes optional, an emergent illusion rather than a fundamental truth, standing at the edge of a timeless universe. All of these discoveries point toward the same unsettling possibility. The universe works perfectly well without invoking time as a basic ingredient. What you call time may emerge from deeper, non-temporal laws, much like temperature emerges from the motion of atoms. you may be living inside a structure that does not actually change, while experiencing it as if it does. If the universe is fundamentally timeless, then every event you consider to occur sequentially already exists within a fixed, four-dimensional structure. The past, present, and future are not created as you perceive them. They are coordinates in a complete space-time manifold. Your awareness traces a path through this structure, giving the impression of movement, progression, and causation. Yet the underlying reality does not flow. What you experience as change is only the perspective of a conscious system embedded within a static framework. This perspective forces a reconsideration of fundamental concepts. Causality, long thought to dictate the order of events, may be a local, emergent phenomenon rather than a universal law. The before and after you rely on are properties of your particular trajectory through space-time. In a timeless universe, cause and effect exist as relationships encoded in the structure, not as processes unfolding over a river of moments. Each event is fixed, and the directionality you perceive is a consequence of perspective, memory, and entropy, not a feature of reality itself. The consequences extend to physics itself. Time, which underpins nearly all classical intuition, becomes a derived concept. General relativity describes the geometry of space-time, but does not require an external clock. Quantum mechanics predicts correlations between states, independent of a flowing present. Attempts to unify these theories increasingly treat time as an emergent property, arising only when larger-scale phenomena are interpreted by observers. The deeper laws of nature function without it. Even consciousness, the anchor of temporal experience, is compatible with timelessness. Your mind constructs a narrative, linking discrete states into a coherent story. Memory provides a sense of duration, anticipation, a sense of future, and perception, a sense of immediacy. These constructs make time feel real, yet they emerge entirely from the processing of information within a static, four-dimensional landscape. The flowing you is a cognitive artifact navigating a pre-existing structure. Entropy and the arrow of time are similarly reinterpreted. What you perceive as irreversible processes are statistical patterns arising from large numbers of particles and interactions. The universe itself does not enforce forward motion. It merely contains states arranged in a way that produces the appearance of flow when observed sequentially. Temporal directionality is an emergent feature projected by observers, not a fundamental property. Cosmology reinforces the unsettling picture. The origin of the universe, the Big Bang, may not mark the birth of time, but a boundary condition in a timeless, informational, or geometric structure. the evolution of galaxies, the formation of stars, and the emergence of complexity can all be encoded as relational patterns. What you interpret as history is simply the manifestation of constraints within the structure. Future states are already present, and the perception of becoming is limited to your embedded vantage point. Standing at the edge of this understanding, you are confronted with a profound shift. Everything you experience as passage, progression, and change may be a feature of consciousness navigating a pre-existing static framework. Time, so fundamental to everyday experience, may be no more than an emergent, context-dependent property. The universe functions perfectly without it. If this is the case, then the flow you trust, the river of moments you inhabit, is a product of perspective, biology, and cognition. Reality itself is complete, timeless, and fixed. You move through it, not because time carries you, but because your consciousness interprets the patterns it contains. Change is perception. Duration is interpretation. And the universe, at its most fundamental level, is indifferent to the passage of time you believe in.